BC, this isn't until chapter 7. However, by the time you get here, I expect you, hopefully, by that point next year, when these results are done, to be able to do integrals in your head with chain rule. I'll show you today what I mean. I'll show you an example that we're about to see. But as you guys are writing, let me just show you something that, when you were in Algebra 1, not many people could do in their heads. But I hope, by calculus, as long as you don't kill a puppy, you can do in your heads. You gonna sure it's 4x squared plus 12x plus 9? Yes. Now, everyone do that in their head in calculus. No, not necessarily. However, can you learn? However, would I have even wanted algebra kids to do this in their head? Probably not. I want them to be able to do it and do it right. And then, once you get more and more and more proficient in math, master the content better and better, have a deeper understanding and a deeper ability, then we start to construct it. Same thing with integrals. Did I even show you guys integrating mentally? Mental math. Let's solve a chain rule integral. Yeah. And some of you do it, and I was like, yes, you're right, yes, you're wrong, or no, you're wrong. And then basically say, but write it out, write it out, write it out. Mm-hmm. Yes. Some of you were doing mental integration, and I was like, careful. But in BC, hopefully we can do a lot more mental math because we have mastered the content even better. Anyway, coming back. Endeavor? Is Endeavor number? I guess I never wrote the number. Got a little. Okay, so then coming back. So by chapter 7, after we reviewed the AB stuff and hopefully mastered it even to a deeper level than we did before, hopefully we can do some mental math with integration. Long story short, with integration by parts, you see an integral, and they have two seemingly unrelated parts that you sub, like, no, I can't do U sub, it's not going to help. Even like integration on track, nope, it's not going to help. So I say, okay, you know what? Integration by parts says there are two seemingly unrelated pieces, which we have up there. Or we have down here. Two seemingly unrelated pieces. Go ahead and write down this example. This is the one we're going to go through. And then we're going to build up to that one. Then we're going to build up to the loop B one, which is really crazy. Okay. You guys just helped me just a second ago think about, okay, if the u becomes an integral of du, yes, it's uv minus the integral of, but what needed to be integrated has now changed to a new integral that I need to figure out. U, I need to take its derivative. V, I get from integrating dv. You guys said, hey, if it looks something like this with an x and a trig, x better be u, and I say, yes, good job. Now, how do we set this up, though? We set this up by saying, well, if x is my u, then, here's how Lucky 7 works. I write it a little bit differently than I did there on the video, but long story short, you say, okay, who is u? X. Well then, who's this guy? dv. I try to show my differentials is lined up and my original functions as lined up. Some people would do this a little bit differently, but the same idea, the same main formula applies. If I have u, how do I get du? Take a derivative. Derivative of x is 1. We put the dx because we have du, dx, the dx is on the other side. If I have dv, how do I go find v? Integrate. Now, what do you notice about my jump from dv to v? Did I show you one? Did I do any use of? Very dangerous. But I was also very careful. I did mental math. What would my u be in this integral? 3x. Okay, so if du is 3x dx, then how do I get dx alone? Divide by 3x. Sorry, divide by 3. Derivative of 3x is 3. Divide by 3. Do you see why there's a 1/3 out in front? And then I have a negative cosine of u? Okay, so mental math. Once I have the derivative of u and the integral of dv, now I'm ready for my formula. And my formula says, read it, the integral of u dv is u times v. Hey, I can't do it with a line. U times v minus the integral of v du. Oh, lucky 7, I get it. u, v, and v du. Ha-ha. So then what's down here? times v, negative 1/3 x cosine of 3x, minus the integral of v, oh, that has a negative, so minus a negative was a positive. Pull the constant out. Minus the integral of v du, so cosine of 3x dx. Now, am I done? And the answer is no, there's still an integral. But has it just gotten simpler to solve? And the answer is yes. What before I couldn't do because there were two separate pieces and no u sub was going to get rid of this x. Now hey, this is just the integral of who? Cosine of u, right? And so if I make my u 3x, well, do you guys see how I did another mental math integration? What's my mental math integration? U is 3x, so du is 3 dx, and so I divide by a 3. Do you see where another 1/3 came from?
Yeah.
So I had a 1/3, I have a 1/3 from u sub. What's the integral of cosine? Sine of u. I still had to write this guy, because he was still a part of the answer. But I was finally able to integrate. And so what is my final answer at the end of the day? Oh, don't forget plus c, it's an indefinite integral. What's my final answer for the integral of x sine of 3x? This whole guy. uv minus, and what I was able to integrate from the integral of uv. Yeah. From that. How can I tackle this one up on the board? Who's u? Good idea. The sine's derivative doesn't really get any simpler. So, we're going to make u x squared, and who's this guy going to be then? You have the formula written, right? Integral of u dv. So I'm going to go ahead and take this guy and say, alright, let's integration by parts. So I have u equals x squared. I have dv is equal to sine of x dx. Okay, how do I get my next piece? du, and I take the derivative. Good, 2x. dx, because we're having it with integrals with du on one side of dx on the other. But I'm missing a piece. I'm supposed to have 4. What goes here? V, and I need to, good, integrate. And people were integrating, do you guys agree with negative cosine of x? Okay. Now, how do I get to say what the integral of u dv is? uv minus the integral of v. So I have uv, that'd be, I'm going to write it pretty, negative x squared cosine x. Sound good? Minus the integral of who? v du. So I have, oh, I can pull out a 2. Oh, but it's a negative 2, so plus. And then I have x cosine of x. Oh, no, we're just supposed to find this integral. Wait. Can we integrate x cosine of x? 2 separate pieces again? Oh, do another iteration. Do it another time. Integration part by parts, part 2. Who's my u? You guys see how the u is going to be simpler this time? Who's my dv? Okay. So when I go to write down, I have u is equal to x, dv is equal to cosine of x dx. Who goes here? And who is du? 1 dx. Who goes here? V, which is the integral. The integral of cosine is sine. Times lucky 7 it, right? So I need to replace this integral, just this piece right here, with uv minus the integral of v du. Do you guys see how this is still part of my answer, right? So I still need to go ahead and write negative x squared cosine of x. I still have plus 2, but I have plus 2 times who? uv, so x sine x. Oh, wait, I took an integral that dx is supposed to be done. I apologize. Minus the integral of v du, which would be sine of x dx. Uh-oh, don't forget that little 2. I think we might have forgotten that. But we haven't finished our integration. But yeah, there's kind of a plus c that needs to come in. I can go ahead and multiply in that 2. Okay. finish my problem. Another integration by parts. No. We're done. Basically. One. Where would it get you though?
Let's come up to 0.
So what's going to be the integral of negative 2 sine of x? So I have minus 2. And the integral of sine is cosine, but it's a negative cosine, right? We can't forget our plus c because it is an indefinite integral. But at this point, you're going to look on Wolfram alpha for the integral of x squared sine of x dx. Guess what you would find? So why does it get any harder? What if what if I had an x cubed? That'd be rough. What if I was to move this and say, hey, I'm going to give you something that's going to need like 3 iterations, like x cubed, not do 4, x to the 4th. Oh, how many integration by parts are we going to have to do? How many lucky 7s? So someone came up with, maybe we can shorten this process and instead use something called the tabular or tic-tac-toe method. And the tabular method says, and I might do a little bit differently than he does, just for sake of organization. So let's say I was to give you the integral of x to the 4th. I could do a trig. Let's do something different like e to the x. E for effort. And the tabular method says you got to figure out who are your u's and who are your dv's. Who do you think you want to be your u? Why not e to the x? What happens to u's? They get derived. And according to our lucky 7 formula, what was my hint for choosing u? Simpler. E to the x is not. But does it simplify my integral? No. And if I integrate x to the 4th, isn't that now 1/5 x to the 5th, and it just got worse? It got worse! So I'm going to go ahead and start with x to the 4th on the u side, and what do you think, or how do you think that we're going to make jumps? Deriving. Because of du, because of the integration by parts formula. So then what must be on the dv side? E to the x. dx is understood, it makes us able to integrate. But what am I going to be doing with my jumps? Okay, I gave you an easy one. I guess it could be fun to make it e to the 2x. Okay, so anyway. How do we integrate e to the 2x? Exactly. That's deriving though. We need to integrate. The derivative is going to be 4x cubed. The derivative is going to be 12x squared. The derivative is going to be 24x. The derivative is going to be 24. And the derivative is going to be 0. 0 is a good sign. That means we reached the end of the world. Okay, so how do I integrate e to the u? U is 2x. Du would be 2. Divide. I need a 1/2, right? 1/2 e to the 2x. What would be my next integral? Good. Times 1/2 again. The next one. Next one. Next one. How many integration by part lucky 7s would we need to have done? A lot. How many are we going to do? Tic, tac, toe, oh. Usually there's not more than tic, tac, toe. He had a third column where he had alternating signs. We always start with positive times the term, negative times the term, positive times the term, negative times the term, positive times the term. And guess what the table does? It answers the question. Remember, 4 over 4 would just be 1. 12 over 8 would be 4/3. No, 3/2, right? (24 over 16 would be 6/4. Oh, 3/2. Again. 24 over 32. 3/4. Now you just add a plus C at the end. You like that? So I'm done. Done. So let's do the lucky 7 way 4 times. Okay. But we could go back to the one that they did, and we could say, well, wait, they did tic-tac-toe on the board, right? Okay. So how we did tic-tac-toe with this guy, and see if it matches up with that guy. Who do we put on the U side? I squared. And who do we put on the DD side? Side of that. Alright, how do we jump? DD side, we're starting with sine, right? What's the integral of sine? What's the integral of negative cosine? What's the integral of negative sine? Okay. Oh, yeah, the u is the other. Wait. Negative x squared plus n of x? Check. Minus the negative or plus 2x n of x? Check. Plus 2 cosine x? Check. So what do they add the n? Plus. Oh, tic-tac-toe! So you want to be crazy? You do 8 times. Huh? What? Oh, it's for either the Friday awards assembly where you get a free muffin, or the Friday night awards assembly where you get recognized with a spiel. Okay, coming back. Like a 30-second spiel. Unless you're not there, you get no spiel. All right, so coming back. What I'm supposed to give you this example. My question is, how would we solve e to the x sine of x? Who's you? All right. So if u is e, then oh, okay.
No, it's x. Okay, you know what? It's x, dude. This is one of the problems with guessing.
Wait, how do I integrate u to x?
It does not exist. X.
Is anything getting simpler?
No.
Tabular method is awesome, except for loopy examples. Loopy examples, he's not going to work because he's going to go on forever. So if he doesn't work, then maybe we should do it the old-fashioned way. Who do you want to be u? I don't know. We just made it e to the x. So if u is e to the x and dv is, some of you are like, you're on a fool's errand, but I'm not. Derivative of e to the x is e to the x. If dv is sine, then v is equal to negative cosine. I'm going to do my integration by parts. My skeptics, just keep watching. Nope. uv, negative e to the x cosine of x minus the integral of v du, which is minus and negative, and I have e to the x cosine of x dx. Oh wow, it's not working. Let's go again. So, to go again. Now, Pause. Don't you dare switch who you're choosing to be U and who you're choosing to be DV. If you switch, you're going to end up right back at the beginning and be really mad. Keep U to be e to the x. Keep dv to be the trig guy. du is equal to e to the x. v is equal to sine of x. True? Integration by parts. Answer. This guy, e to the x sine of x dx, is equal to, well, keep him, he's still a guy. He's still a term in my expression or my answer. Plus, I need to integrate. Oh, hey, I have my integration by parts. So I have uv minus the integral of v du. This is impossible. Go again. No.
That's the answer.
No. We're 2 steps away from the answer. In Algebra 1, didn't you use certain colors and geometric shapes to combine like terms? Show like terms? They're like terms! Algebra returns! 1 plus 1 is 2! Yeah, it is. But don't forget, it's an indefinite integral, so... Dun, 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 dun. Wow. It's called a loopy one, but why is it called a loopy one? It loops back around. And as soon as they match, we can combine like terms, which is not always that nice, but it is possible to combine like terms. People on yellow sheets for Friday night. Josh, Wayne, Eileen, Wait, is this for? I think it's Friday night. Kyle, Christina, Emily, Susan, Bree, Joyce, Jonathan.
No warm up. No.
No, nothing's for Friday morning. That must be different. I don't know. Josh, Eileen, Joyce, Lucy, you have one too. Sorry, you got stuff.
Yeah.
You're going to figure out multiple classes. You guys know that, right? They just kind of keep on randomly setting up.
Yeah. What is it? He broke the perfect record.
Oh wait, class, I forgot! Class folder, handout, bonus, integration by parts worksheet. Nothing as hard as the loopy, I don't think. Example, due in a couple days for a double bonus homework, 10 points in the homework category.
Hey,
So there's an integration package. Okay, then I see Henry, you show me a picture. I want to look at my wall and I get it before my